4a says, actually I'm going to do 4b, because I want to remind you of one more thing. Exactly, it's improper. It's not an improper integral, it's now an improper fraction, because you've got a larger degree on top than you do on bottom. Because we don't do enough long division.
It's just not it's unnecessary.
It's absolutely necessary in this case. Do you see again, the problem is this and this, right? So in order to do this, you've got to long division of polynomials. So you write the dividend, which is the numerator inside x cubed. What have I got to remember to do inside? Plus 0 x squared minus 4x plus 1. Outside is x squared minus 3x plus 2. Here and here. What have I got to multiply x squared by to get to x cubed? The answer is x. And now multiply x cubed minus 3x squared plus 2x. And now subtract, so change all the signs. X cubed minus x cubed, gone. X squared plus 3x squared is 3x squared. Minus 4x minus 2x, minus 6x, plus 1. So up here I write now, what have I got to multiply x squared here by to get to this 3x squared there? Answer is 3. So 3x squared minus 9x plus 6 minus plus minus. Change the signs and then add. That's subtraction. Boom. 3x minus 5, right? So that makes this plus 3x minus 5 over x squared minus 3x plus 2. Integral of x plus 3 plus 3x minus 5 divided by x squared minus 3x plus 2 dx. It's supposed to be hard. Oh, okay. It's the hard that makes it great. That's the great line from League of Their Own. You've seen that movie. There's no crying in baseball. It's the hard that makes it great. If it wasn't hard, everyone would do it. And it's like being a math major. It's being an engineer. I mean, you could get your English, your history, your psychology degree, business. Come on. Yeah, but they're going to be working for you someday.
College sports make you age fast.
Yes, it does.
So we're aging your bodies on one end, and we're aging your brains on the other end. All right, so these two are easy. X plus 3, piece of cake. Let's consider this guy. I'm going to be looking at 3x minus 5 over, by the way, I want to factor this now. Can you do that?
It's 4 and 1, so it's a negative 4 and a positive.
Okay, you're going to split it, but then you factor by grouping. I'm going to do x minus minus 1 and 2, 2 and 1, either way. Yeah, I think there's that intermediate step you do like x squared minus x minus plus, no, not plus x minus 4. No, never mind. I don't know what I'm doing. Ignore me. Okay, so we factored that, we get this. So partial fraction says we're going to rewrite this as what? We want to break this into two fractions added together, each with their own factor in the denominator. Well, the trick here is we want to know what do the numerators have to be so that you get 3x minus 5 if you started with this. So we don't know what goes here, and we don't know what goes here. So that whenever you combine them together using lowest common denominators, you get 3x minus 5 on top. Okay, I'm going to take just a quick look back at 7.4 and show you that we had several cases of situations that we had to be aware of. Case 1 was when the denominator was all a bunch of just simple linear things multiplied together, like what we have now, but no repeats. All you have to do is one fraction for each. An A over one, a B over the other. I used subscripts to indicate that, but that's exactly what we did here in this example. That was case 1. Now, case 2 was what happens if you have a simple linear thing like x minus 1, but it's squared. When you split it up into partial fractions, you have to have one for the first power and one for the second power. An x minus 1, an x minus 1 squared, and then one for the other factor. But you just have an a, b, and a c in the numerator, but you have to have one for each power if it's got a higher power than just the first power. Where things got complicated again is what happens if one of them was a quadratic in the bottom that wouldn't factor, like x squared plus 1 or x squared plus 4. The numerator had to be 1 degree less, which was a linear. So that's why we got like the bx plus c. By the way, you're going to have to do that on D for sure. On 4D. And then one we didn't do is where you actually have repeated ones of quadratics. That gets painful. By the way, if you had cubics that don't factor in the denominator, you'd have to have a quadratic in the numerator. We didn't talk about those. If you have repeated cubics in the denominator, you'd have to have one for every power of that cubic. And you'd have to have quadratics in the numerator. If you have quartics that don't factor, it goes on forever. But the point is, this technique covers all rational functions. All right, so back to our simple case. So nice to give you a simple case.
X squared plus x minus 1 equals 8 times x minus 2.
Close. What I would do, I think is kind of what you're doing. I'm going to take this whole thing right here and multiply both sides by that. So as long as I multiply both sides of the equation by the same thing, multiply through by LCD. On the left-hand side, it completely cancels off. On the right-hand side, when I multiply it times this first term, the x minus 1's cancel, and I've got a times x minus 2. again, just so you know what I'm doing. I'm multiplying both sides by x minus 1, x minus 2. So I multiply that by x minus 1, x minus 2, x minus 1, x minus 2. And multiply this by x minus 1, x minus 2. Over here, they all cancel. Over here, the x minus 1's cancel. And over here, the x minus 2's cancel. And it gives me this equation. And I gave you the long way to solve this and the short way. What's the easy way to find your A and your B?
So you just multiply everything by x minus 1, x minus 2.
Yep. But now I'm still trying to find A and B so that this equation is true for all x. The long way is to multiply out the right-hand side completely and put all the x's together and all the non-x's together. Set the x coefficient equal to 3 and the rest of it equal to negative 5 and solve the resulting 2 by 2 equation. That's much harder than it needs to be. What's the shortcut? Why 2? Remember doing that? That makes this term 0, and all you've got is a b term left. So your only unknown is b. Okay, so let x equal 2. On the left-hand side, we get 3 times 2 minus 5 equals a times 2 minus 2 plus b times 2 minus 1. I just wrote it in so you could see it, but actually we could do that in our heads. We get 1 is equal to b. What else would you think is a good choice? Okay, so 3 times 1 minus 5 equals a times 1 minus 2 plus b times 1 minus 1. 3 minus 5 is negative 2 equals negative a plus 0, so a is 2. Okay, so here's what we now have. All together, from this integral up here, right, you have integral of x plus 3 plus, now 3x minus 5 over x squared minus 3x plus 2 is now this thing with the a's and b's plugged in. So plus 2 over x minus 1 plus 1 over x minus 2 dx. And now that's easy.
You just plug the numbers in for x.
You mean right now to do the next step?
Yes.
Now I just integrate.
X
X squared
squared
over 2.
plus 3x.
Right, integral of x, x squared over 2. Integral of 3, 3x. Integral of 2 over x minus 1.